Okay, we're going to look at different equation types. Of course, if I just have a variable and it equals a number such as 9, that's an equation. That's telling you that one thing is set equal to another. And that is all the definition of an equation is, that one thing is set equal to another. Now, let's expand this. What if I take that variable and I multiply it by something, okay? And then I set it equal to a number. All right, we know intuitively that 3 times some number equals 9. So 3 times 3 equals 9. But how do we get that? What we're doing is we're looking at what operation these two, or what is going on with the x. So your first step one, is what operation is going on. Identify your operation. Okay, so the next step is to reverse that operation. We're going, and what we're doing is we're finding the inverse of that operation. So the inverse of that operation is division. So we're going to divide both sides by the same number. Why the same number? Well, on this side, it is going to cancel, and we divide on this side to keep the equation balanced. So that leaves us with x equals 9 over 3, which is 3. Okay? Okay, so let's say we have an x over 5 equals 20. All right, now what's happening here is my first step is identify my operation. So it's my operation, identify my operation. My operation is division. What's happening to the x? So I'm going to divide, I'm dividing x by 5. So I'm going to find the inverse. Okay, so I need to find the inverse, which will reverse it out. Okay, so the inverse is multiplying both sides by the same number, which will cancel out on this side, and we know that's 5. And of course, you're doing 5 over 1, and then that's canceling out, and we multiply by 5 on this side, which is the same as 5 over 1. Of course, you had 20 over 1 here. And when you multiply fractions, you multiply the numerator times the numerator and the denominator times the denominator to yield x equals 100 over 1. 20 times 5 is 100, and 1 times 1 is 1. All right. Now, the other two steps are to cancel, which is what we did with this 5 on this side, and to balance. Okay. All right, so what happens if I take an equation such as this, 3x plus 2 equals 14? Well, in this case, we are going to follow the order of operations in reverse. Normally, the order of operations, if we were to evaluate this, we would say 3 times whatever x is, then let's say x equals 1. We'd have 3 times 1 plus 2. Now forget about the 14 for a second. Now, normal order of operations, we'd figure out this first because it's multiplication. And then we'd add the 2. And then that would give us, that's how we would work it. But when we're solving an equation, what we do is we go in the reverse order of the order of operations. So we're going to look at this. We're going to look at this right here and see what operation this is. And we're going to find its inverse. So the inverse of adding 2 is actually subtracting 2. We're going to cancel. Remember, we find our operation. Then we get the inverse. And we're going to cancel. Okay, so we're going to cancel on both sides here. And then we're going to balance, which is the 14 minus the 2. And so what we end up with is the 3x, and line up your equal signs too. Now this part right here, plus 2 minus 2 is equal to 0, okay? And then 14 minus 2, and you remember to follow your rules for sign numbers. 14 minus 2 is the same as 14 plus a negative 2, which gives you, you're going to find the difference, which is 12, and keep the sign of the larger number, which is 14. So that answer is going to be positive. So the answer is positive 12. Now we're going to follow this same process again. Figure out the operation, its multiplication. We're going to find its inverse, which is division. We're going to divide this side to cancel. And we're using the same number. And then we're going to use the same number on the other side to balance. That leaves us with x equals 4. So let's say we have another equation, 4x minus 1 equals 7. Okay? Again, we follow the order of operations in reverse. We do not deal with the multiplication first. We deal with this addition or subtraction. In this case, we identify the operation is subtraction. And so we're going to add a 1 to both sides. And then we're going to add it over there, of course. What we get is 4x equals 8. We're going to identify the operation again, which is multiplication. We're going to divide both sides by 4 to cancel on this side and balance on this side. And then, of course, we end up with x equals 2. What if we had an equation like x over 5 minus a negative 1 equals negative 6. Okay, and what we're going to do here, we still deal with the addition and subtraction first. Now notice this right here, we've got a minus a negative 1. To count to cancel that out, you have to add the additive inverse. So what we got to do to be careful so you don't make a mistake, you change the subtraction when you see a minus or negative to plus a positive 1 equal -6. This so you won't get confused as to what to do. Now your operation's addition, and then you just subtract the 1 here. Okay, see, it would have been a little unclear what to do if you had not changed this first. So we're going to subtract the 1, subtract the positive 1. So now we're going to have x over 5. This becomes 0 right here. And then that equals a -7. Now we identify the operation here. This is division, so we cancel it out or find its inverse, which is our second step. We find that inverse, which is multiplying by 5. We multiply by 5 on the left to cancel and by 5 on the right to balance. And you end up with x equals -35. Okay, let's say you had 3x plus 1 equals 2x plus 6 minus 4x. In this case, we've added two things. We've got a variable on both sides of the equal sign, and we've got two variables on one of those sides. So the first step is to collect all your like terms on both sides. Okay? So in this case, you just add them up. 2 minus 4 is -2x. Then plus 6. And then this is 3x plus 1. Now what we do is we choose, the next step is we choose to get all of our variables on one side. Let's just move them to the left. All right, so the way we do that is we cancel it on one side and we balance it on the other side. So you cancel it by just adding it, the opposite of the number. So we got a -2x, we're going to add a positive 2x to both sides. Okay, this is adding right here. The number sign, if I don't write it, is understood to be positive. So I could have written it plus a positive 2x. That's the same thing. Okay, it's understood up there. The operation sign is addition, that's here, and the number sign is positive, that's there. Okay, so what we do is we add all this together. This is called simplifying. Simplifying means just to add stuff together or reduce the fraction or collect like terms. So it's going to be 5x plus 1 equals 6. And this is one of the equations that you already know how to do. Incidentally, the next step is to get all the numbers on the opposite side of your variable. And you do that by adding the opposite of the number. Okay? So adding a -1 is the same as subtracting 1. Because if I go 5 minus 1, that's the same thing as me saying 5 plus a -1. Okay, so if I add a -1, it's the same as subtracting a -1. You can also just think of it simply as subtracting 1. Okay, and we will subtract 1 on the left to cancel, subtract 1 on the right to balance, and then we end up with 5x equals 5. We look at our operation, identify our operation. It's multiplication on the x. We find the inverse, which is division. We divide by the 5 on the left to cancel. We divide by 5 on the right to balance. And then we end up with x equals 1 as our answer. Next, we have what we call the distributive property. The distributive property states that if I multiply something times two items that are grouped, I take the A times the B first, and then I keep the operation, and then I do the A times the C last. Well, what does that look like? If I have a 3 times a 2 plus 1, that's the same as 3 times 2 plus 3 times 1. All right, 3 times 2 first and 3 times 1 last. Order of operations on the left side would yield parentheses first, so we'd have 3, and then we'd be multiplying it by this 3, and then order of operations would tell us that this would be 9. Now if we look at the left side, the right side, order of operations, we do multiplication first, and then we do that from left to right, so that we would come here, that would give us 6 plus 3 times 1, and then we would do order of operations again. That would give us 6 plus 3, and then finally we would do the addition, and that would give us 9. So on both sides we have 9 as our answer. Now we use the distributive property to clear parentheses in equations. Okay, we have this equation here. What we do is the distributive property first. We'll just start on the left side, doesn't matter which side you start on. So you would have -4 times x. Now the distributive property works on the subtraction too, so you have -4 times x, then you have minus, okay, then -4, and I'm gonna just put a parenthesis here just so things don't get confusing. -4 times the 2, okay? Just keep the operation and then multiply the two numbers, -4 and the 2, plus 6x, and then that equals 3 times 2x, so that's going to be 3, and I'm going to put parentheses around here. 3 times, let me get that right, 3 times the 2x okay, and so if you had the 3 times the 2x, that would go here, plus the 3 times the 1, and then minus 5. And we're just going to simplify this by using our order of operations. This part becomes -4x. This is minus Negative 4 times 2 is 8. Negative 8 minus a negative 8. All right, plus, and you can put parentheses around that negative 8 if you want to just kind of keep the sign straight, but it doesn't matter. Plus 6x. Keep lining your equal signs up. And it's going to be 6x right here. Plus 3 minus 5. Now once you've cleared the parentheses, that's your first step, is to clear the parentheses using the distributive property. You simplify it, and now you can collect like terms. All right, so negative 4x plus 6x on this side will be 2x minus a negative 8 equals, and we're going to collect like terms on this side. 3 minus 5 is negative 2. So you got 6x plus a negative 2, or you can say minus 2. It doesn't matter. All right. So let's do plus a negative 2. Since that's what you come up with when you did 3 minus 5, which would make it 3 plus a negative 5. You find the difference, which would be 2, and keep the sign of the larger absolute value, which would be the largest absolute value would be negative 5, and so the answer would be negative 2. All right, so now we need to decide which side we're going to get all of our variables on. Let's just try the right side. So I'm looking at the operation on 2x, and I'm just going to cancel it out. Negative 2x. And so that leaves me with a negative 8. Now, incidentally, you can think of these negative ones as negative 1 times negative 1. That just gives us a positive 8. So we can rewrite this as a positive 8. And then over here, and the reason why you can do that is because if you were to look at this right here, you really would be writing a positive 8 right here if you were to keep change. So that's how it's equivalent. All right, so now we're going to have 6 minus 2x, which will be 4x plus this negative 2. And so this negative 2 right here, this is one of our regular old equations again. So we look at the operation and we go in the reverse of the order of operations. And so we're going to, now we're adding a negative 2 here, just add the opposite, which is adding a positive 2, which will cancel it out. And we're going to do it to both sides. And when we do that, we get 10 equals 4x. And I'm going to look at my operation, identify my operation. It's multiplication times the x. So I'm going to find the inverse, which is division. I'm going to divide by this number that's being multiplied in order to cancel on this side. I'm going to divide by that same number in order to balance on this side, and I get x equals 10 over 4, okay, which is 5 over 2, okay. And that equals 2 1/2, okay. And what does that equal? That equals 2.5 as a decimal. And you need to remember how to convert between fractions and decimals. Okay, that's how you solve equations.